Hello, everyone. Thanks for joining today. I hope you all enjoying the reInvent sessions. Today, we're going to have a session on multi-agent collaboration with Amazon Bedrock AgentCore for advanced security operations. Okay, how many of you here from security operations or security that reports to the CISO team? Anybody here? Good. So how many of you are developers here? Okay, good. How many of you guys used AgentCore so far? That's good. It's a quite good time. Okay. Now, this session is more focused on how to leverage AgentCore to run the security operations using multi-agents. Okay. Now, my name is Venkata. I'm a senior solutions architect. I'm with AWS little over 6 years, and I'm based out of New Jersey. And I'm also a specialist in AML and as well as resiliency. Today, I was joined by my colleague, Eric.
Hi, I'm Eric Hortson. I'm a solutions architect based out of Atlanta and a specialist in machine learning and agentic solutions. And I'm going to be walking through the code demo today.
Yeah. So today we're going to present what is the challenge that we are trying to solve in the security operations, okay? And how we are going to leverage AgentCore and a little overview on AgentCore, Bedrock AgentCore. And then we're going to talk about the solution that we want to deploy, and we want to run the security operations. And we're going to followed by a code talk, which Eric is going to walk through the code. And we want to make it more interactive, so feel free to ask me any questions, and we'll happy to address that. Okay? And there will be a demo after the code talk as well. Okay? Yeah. Now, some of you are coming from the security background, and some of you coming from the developers background when you raised hands. As a solution architect, I worked with day-to-day with multiple customers across the organization and then outside of my organization as well. So when we work with the customers, I mainly ask the question with the customers, what are the things that they focus on? And they always tell me two things. One, strategic, and they always look for the operationals. When it comes to operational specifically for security, when I interact with the security team, they always say that we always work on the repetitive tasks. So when I did a deep dive on that, what do you mean by repetitive tasks? They're going to talk about, we do get a lot of alerts from different security services that we use, okay? And we spend a lot of time on reviewing those or investigating those security alerts. And they work on the remediations, and they're going to summarize it, and they're going to send an email to the entire leadership or the organization that they report. So those are the repetitive tasks. And it is based on the not a specific use case or specific environment. It's every organization that I had this insight. Now, most of the time they spent on the manual work. So they have to do the investigation, they have to remediate it, and then they have to send the report. And that becomes a complex and operational burden. Okay, and these teams are more focused on the operational rather than on the strategic initiatives. Okay, if it is a task is repetitive, we want to automate it. And we want to leverage the agents here, and that's how we want to leverage multi-agents in security operations today. Okay. Now, how do we do that? Okay. Now, if you look at it, we have 3 steps that we follow when we get an alert as a security team. So can anybody tell here? So when you get a security alert, what exactly you guys do? Can you describe in 3 steps? Anybody in the room?
We start with investigation.
Okay. We start with the investigation. Okay. What is the alert is about, how it is impacting. Okay. And then we'll go to the second step where we want to do a remediation. Okay. There is 2 steps of remediation. The first one is we want to tactical, which we want to fix it immediately so that it won't impact the entire environment. The second step is we want to fix it for long term as well. Okay. If that we should not see that alert again and again, right? So those are 2 steps that we follow. That's the second step. The third one is we want to do we call it as RCA, but we want to do an entire end-to-end report when the alert came and what did we do and how did we fix it, okay? So those are the common 3 steps that we see in a workflow for security operations, right? Now, if you look at those 3 steps and they are repetitive, for any alert, it's a repetitive process actually. There's no change, okay? Primarily, we're going to leverage those 3 steps to build 3 different agents to work for us to do this work, okay? The security operations work, okay? Now, for that, we're going to leverage Amazon Bedrock AgentCore, okay? Platform is fully managed, which gives you flexibility to build, deploy, and run the multi-agents in secure way, okay? Now, within the agent core, you have the runtime where you can build the agents using multiple models and as well as different frameworks like LangChain, LangFuse, and Crew AI, okay? That's the agent frameworks that you can bring in. And we also have AWS Strands SDK, this agent framework that you can use to build the agents, okay? Now, as an agent, that's the runtime that we're going to build it, and we're going to run that agent in the runtime itself, okay? Agent core. Now, similar to the humans, agents also requires certain memory capabilities, certain access to the internal systems to analyze the events, okay? For that, we have agent core gateway, which will help you to connect to the different tools. Like humans, when we get an alert, we'll connect to some CMDB database to identify the details, what kind of server it is, and how is it impacting, and when should I patch that server, and what is the patching schedule. Everything resides in a CMDB, okay? So as a human, I'll just log into the CMDB and identify that. Similarly, agent needs to have similar capabilities to log into the CMDB, identify the details, and create an impact analysis report, so based on the alert, okay? So we need to give same capabilities to the agent to work as a human for this workflow, okay? Similarly, we have agent core browser, which will give you interactions with the browser interactions. Okay, right now we're not using it, but we also have agent core identity. In order to connect to the internal systems, you have a username and password. Similarly, you want to control when the agent is trying to gather the details from internal systems. We need to provide some kind of authentication mechanism, an authorization mechanism, so that we can control what agent can see and what agent can use, okay? At the end, we want to make sure that what are the actions that are performed by the agent, we want to log it, and we want to track it. That's where agent core observability comes into picture. So combining all these components becomes an agent core platform, which will provide end-to-end single platform that you can build the agents, deploy the agents, and run the agents at scale and securely, okay? That's where we're going to leverage today to build our solution. Okay. Now, this is the architecture that we are trying to build today, okay, to deploy the agents in our environment to take care of the security operations, okay? This here, if you see on the left side, I have Amazon Inspector and Amazon Guard Duty. Both are our security services, which monitor our AWS services on the network. And they publish the alerts based on the anomalies detected in the environment. They're going to publish the alerts to the event bridge. And then a Lambda picks up that event and pass it to the agent core runtime, where you see a orchestration agent that is running in the runtime, agent core runtime, okay? The orchestration agent is going to send that alert to do the investigation, remediation, and send a report. It is going to send that request to 3 different agents to run within the runtime. And those special agents are going to work with your internal tools, like connecting to your CMDB, connecting to your playbooks to remediate the issue, okay? The entire solution is built on agent core, and that works with all the other existing AWS services, okay? Now, with that said, little bit zoom into what exactly we do with the agents. Now, we talked about we are leveraging multi-agents to build that solution, right? Again, investigation agent, once we receive the alert, we want to investigate what is that alert about, and then we want to work with internal system to gather the information. What is the server that is impacted? What is the software or the OS that is currently running there? What is the patch schedule? You don't want to update a server while in the middle of the production. You want to understand the server nature and the workload that is running on the server, and based on that, you want to take that action. Those details, everything is residing on the CMDB, so that investigation agent is going to work with the CMDB through agent core gateway, pull all the information, and it does the investigation report. It's going to prepare the entire investigation report. So alert, how it is impacted, and what server is impacted, and what the schedule look like. Once that is done, we have the second step. We want to remediate. Here we created 2 agents within the remediation itself, containment agents, where one of the agents is going to prepare a script for you to build as a playbook, basically. You have a non-production system, some production systems, and you don't want to operate by an agent in the production systems in some cases. For that, we create a playbook. So when the operator receives an alert, he doesn't have to go to the internal wiki pages or different nodes, what exactly the next step he wants to do. We are going to build a playbook for him so that he's going to follow the steps. In the second containment agent, which we call it as executor, that can automatically remediate the issue. Okay? It is not going to create the playbook, it is going to execute the playbook. Okay? It is going to take the alert, investigation report, and it's going to apply the remediation work. Once everything is done, that's third step, which is the reporting agent actually. So there was an incident happen, there was an issue happen, okay? And you want a summarization report end to end. We received alert at 9 o'clock, we did this investigation, and we fixed it, and this is the solution that we applied. End to end, we need a report that we want to report it to our senior management, or we want to keep it in our records so that we can build a context end to end going forward, okay? So this is the 3 different agents that we are using, and we are going to attach it to the orchestration agent, which is going to manage all the agents, okay? So let's move into the code talk today, okay? So how do we build this solution? And Eric is going to cover that. Eric, over to you. Yeah.
All right. So who here has had to deal with a remediation investigation of a security incident within your environment? So this scenario may sound familiar to you. Several years ago, when I worked at a large manufacturing company, I got a call from my SecOps team saying that my AWS account had been quarantined because of suspicious activity. And they had detected that several extra large instances, EC2 instances, had been launched in the account in the short period of time. So, that's the type of call that is going to ruin your evening plans or your weekend plans or whatever you have going on. So we got to work doing the investigation, doing the forensics work, trying to find out what user role profile launched these instances, what was the entry point that they accessed. And I have to admit, I do love the forensics work. It may be a little bit odd, but I do like going through the logs. It turns out in that instance that one of our DevOps engineers, troubleshooting an issue, launched a Jenkins server, didn't change the default password, left some ports open to the world, and somebody decided to set up a Bitcoin mining operation within our account. And luckily, we caught it and were able to shut it down. I'm going to walk through how we could do that with Bedrock AgentCore.
Without human interference. So once we receive the alert, the agents are going to work by themselves and then remediate the issue as well. Okay.
So what are we going to cover? We're going to go through just some basics, setting up the agent. We're going to set up some tools that the agent can use. We're going to create a security analyst agent first using Strands agent, and we're going to show how to orchestrate multiple agents using a graph pattern. And then we'll go into how to scale that agent, so deploying the agent, making it autonomous, and then some tips for helping the agent follow a more deterministic behavior.
Yeah. So when we mean by autonomous agent, basically we're talking about single alert right now for the demo purpose. But how do you want to scale it for different types of alerts? And the workflow remains the same, and the agent remains the same, the work remains the same. So we want to make it more autonomous so that it can make the decisions. Yeah. Go ahead.
So first, just to give an intro to anybody who is new to agents, the Strands agent loop or an agent loop, what it does, it takes in the input. So you can think of this as your prompt, but it also includes the system prompt, which acts as the job description for your agent. It includes the tool specs. So your agent has tools which are essentially APIs or access to external systems. And then there's the actual query and task, that's your prompt, and then the conversation history for what may have happened previously. That feeds into your agent. It starts with reasoning, so your large language model, your LLM, processes that, looks at the tools, makes a selection on tools, executes the tool. The output of the tool feeds back into that reasoning, and that loop continues until the agent decides, okay, I've completed this task, and then it gives you the response.
Here we are using Strands agents in the loop, the framework to build the multi-agents. You can leverage LangChain, you can use Crew AI, and you can use LangFuse as well, okay? You can use any agent framework and deploy it to the agent core, yeah.
So just some basic setup and imports. You can see I'm including strands and I'm including some MCP tools. I have some utilities that I've included as well. I'm not going to go through those because they're less, they are helper functions. And I want to get into the tools. So what are some of the tools that we need? We talked about maybe having access to our configuration management database, our CMDB. We want access to the log files. We want access to forensics, a data store to store any of the forensics reports that we do. And if you've used Strands agents, you may know that you can build tools directly within Strands agents. So why are we using Bedrock AgentCore gateway for hosting these? It's really to maximize the reuse. So we may have multiple agents that need access to a CMDB tool and access to logs. We want to allow all those agents to access these tools without having to build them in every agent.
These tools are similar tools that we, as a human, we use to interact and get the information to analyze the alerts. Similarly, we are giving that tools to agent to do its investigation. Yeah.
So what is the gateway? The gateway provides an interface between an MCP interface, Model Context Protocol interface, between the agent and the tools. So in this case, I'm going to give the gateway some permissions. I'm giving it permissions to invoke 3 Lambda functions that I've created for this purpose. So one, you can see the first one is a CMDB function. You can see the second one handles our artifacts, and then one that does notifications, so sends emails out. So I'll need to give the gateway permissions, and once I have that set up, I'm going to go ahead and create the gateway. What does it take to create a gateway? You need a gateway name, you need the role that we just looked at, and then you define the protocol MCP, and then I save some output from the gateway so that we can get into our next step, which is adding targets to the gateway. So what is a target? Target is the tool spec. That's the endpoint that the gateway uses. So in this case, that consists of 2 things: a Lambda function, the ARN for that Lambda function, and then the tool spec is a JSON schema defining the various functions and operations within that Lambda function. So we can see here that there's a save artifact operation, and it takes a finding ID and a file name. There's a list artifacts operation and a get artifact operation. So those are functions that are defined in my Lambda that interact with my forensics data store.
So these are the tools that we didn't even go to the agent sets. We are setting up the tools that agents can use it. So this is the first step. Yeah.
So I've defined the tool, I've defined the tool spec. Now I want to add that target to my agent. And so I do that by creating a target. I give it a name, I give it a description. This is what helps the agent, when it's going through that agent loop, know what tools are available and how to use those tools.
The agents are going to leverage the LLMs to select the specific tool based on the alert that it received. Does it have to contact the CMDB or doesn't have to contact the CMDB? It depends upon the alert and the use case. Yeah. So go ahead.
Okay. So now we have some tools. I have a gateway that's loaded. If suppose in any enterprise environment, you're going to have some tools that run in AWS. You're going to have some external tools or some things that are you may have your CMDB with ServiceNow or somewhere else, and you need an easy way to authenticate to those MCP servers. So AgentCore provides AgentCore identity, which will securely store your credentials and provide you with a way to securely get and generate and refresh OAuth tokens to access those external services. So that's what I'm doing here. I'm getting an access token to a gateway that I've created that has some of the tools that we have. and I'm loading those tools in the MCP server, and we can see here that it's loaded the CMDB tool, the forensics artifact tool, and my notification tool.
Yeah. So all we did is we create the tools, and we connected the tools to AgentCore gateway, and we provided the authentication. That's it. So for the tools are ready, now we are trying to build the agents. So okay.
All right. So let's talk about what agents we might need for our security operations. We'll start with building an agent that does investigation to gather details, that first step in our process. And in many environments, you already have runbooks. You can use your runbook to guide you in creating the agent through prompts. The other thing I'm going to include here is Strands comes with a set of community package tools. One of those is a use AWS tool. And so I'm using that within this tool. And what that does, it provides access to your AWS resources through the AWS SDK. So what does the agent consist of? It consists of a name. It consists of the tools. So I've got use AWS. I've got the tools that we just loaded. And then it consists of a system prompt, which, as I mentioned earlier, is the job description for our agent. So in this case, the job description is you're a security analyst. You'll be given a guard duty finding. Go and gather details around that and fill out this report. And then to help the agent know when to exit the agent loop, I'm telling it, stop your analysis when you have information you need to complete the report. Only go and get the details that are needed for the report. And then save the completed report. And you can see throughout here, I've specified the tools that I want it to use to help it execute more efficiently.
This is similar to your human security analyst. We are just creating an agent and assigning that role as a security analyst so that it can work as a human agent. Yeah. To do the investigation. We're not done to the containment yet. We're just starting with investigation. Yeah.
So here I'll just show you what's in that report template. In this case, I'm asking for resource details. I'm asking for the VPC configuration and the security groups. In a real-life scenario, you would probably ask for additional forensics logs from CloudWatch, from CloudTrail, from other systems. Okay, so then I want to run the investigation. So I need a guard duty finding ID, and I need to load that in. So let's look at this finding. This is a finding that I have set up in my demo account. One of my EC2 instances is querying a domain name that's used for nefarious purposes. So that's going to be part of the payload to my agent. That goes in as the task. And I will go ahead and execute the agent. So it's going to error. It will gather the necessary information. It'll walk through the tools that it's using to execute the operation. And it'll tell us what it's doing along the way. So it's getting the instance details. It's getting the security group details. It's getting the subnet details. And it compiles all that into a report, which then I can is saved in S3, and I can display that down here. So we have our, that only took a few seconds. We can see that it's got a security operations report that includes the details and executive summary, all the sort of things that we need.
So if you look at it, if you want to employ this one in the human loop or human execution, you have to log into the different service. You have to log into the EC2 instance, and you have to check there. You have to go to the CloudTrail logs and CloudWatch logs to gather the details. You have to go to different places to identify exact location of the resource, and you need to get all these details. But agents, they do it on behalf of you. So they connect to the different resources, and they pull that information related to that alert, and then it's going to generate that risk report. Okay. So for that reason, we created the tools a few minutes back. Yeah.
Yeah. We can see the subnet details and everything that it pulled. Okay, so we've got our first agent. Now what other agents do we need, and how do we orchestrate them to work together? So we talked about having a containment agent to do remediation. In this use case, I've created a containment helper agent and a containment actor agent and a report agent. And I'm combining those with, in this case, a simple graph pattern. The graph pattern is, it starts with investigation, which we just saw, and then I have two branches following a flow. So on the right-hand side, we allow mutative actions, and that will go to the immediate containment. So think of your non-production systems. In my story earlier, that was a developer environment. There's no problem in shutting that down immediately. But you may have highly sensitive production systems. You don't want your agent to go and shut down your EC2 instances or block, turn off security, turn off your roles, block access to that instance. So you want to create a containment script. So those are the two paths. And then in both paths, we're going to generate a final report. So what could go wrong with a use AWS agent that has access to do things? How do you control permissions for the agent so that it can only perform actions in the location, in the environments where you want it to perform actions? For that, we want to use attribute-based access control policies. And this is what allows an opt-in pattern for your environments and your resources. What does that look like? So the agent, you create a agent role policy. So this is a policy that the agent uses when it's executing, and it has under the actions, you can see we have it allowed to do stop EC2 instances, start EC2 instances, et cetera, and it has a condition, and the condition says if it has this tag, allow mutative actions by role, and the tag matches, and I don't give it a role name, I give it a variable. I say it has to match the actual agent role name. Yeah. So then within my EC2 resources, I say allow mutative actions by role, and I set the value of that tag to SecOps agent. And within my IAM role, I also have a tag that says the agent role name is SecOps agent. So if those match, then the action is allowed. If those don't match, or if that EC2 resource doesn't have the tag present, it's not going to be able to, the agent won't be able to perform any mutative actions against that resource. So that's the key of the opt-in pattern. As a DevOps engineer, as an engineer, I have to go and add that tag to my resource in order for the agent to be able to act on it. And so I can choose to do that or not do that based on the sensitivity of my system.
Basically, we are assigning a role to the agent and what agent can perform on what resources actually. And then this role is based on the tags, and you need to apply those tags to the resources that you want to be managed by the agent. Okay? So we are getting the fine-grained permissions because we don't want to turn one incident into another incident. So we want to limit what agent can do and what agent cannot do. So that's where we are choosing to add that role and assign it to the agent. Okay. Yeah.
All right. So to actually create the graph pattern, let's go through the steps to do that. I'm loading some of the pre-built agent code that I specified above. We have the investigation agent, containment helper, containment actor, and a report agent. And I'm using Strand's Graph Builder. So the Graph Builder has really two components. You add nodes, those are your agents, and then you add edges, and that's the traverse points between your nodes. So we can see the nodes I've added: containment, investigation, report. And then the edges, investigation goes to the containment actor and the containment helper, and I've specified a condition, if and only if allow mutative action. And that function, that references a function that I have that goes and looks at the tags on the resources and decides what to do, or tags on the CloudFormation stack and decides what to do. It could look in my CMDB database. It can look in various places. So that's one way to control some deterministic behavior in your agents. And then both go to a report. And then finally, we have the set entry point, which we're setting the entry point as the investigation. We have some controls to set the max number of executions and a timeout. And then we use a graph builder to build that, and that becomes our orchestration agent. The output of that build command, that's what we actually call to invoke the orchestrator. So we, again, can get the findings from guard duty and that becomes our prompt. And the result of the action is, if we run this and let it get started, it will begin investigating this incident and provide a response.
So we added the timeout and we added the executions number, making sure that agent is not going to continuously loop it by itself. So we want to exit at some point, okay, if something goes wrong.
That'll take a few moments to run. Here's what I ran this just before the session to show you the incident response report. It gives an executive summary, affected resources, and then actions taken, investigation findings, and containment action. So in this case, I had it perform the actual actions on my account. It created a forensic snapshot. It isolated the security group. It revoked some IAM permissions, and it shut down the instance and blocked some DNS communication. So it did the actions and provided the report, all without me having to do any manual work. Okay, so let's step on to part 2. We've got some agents. We've got agent orchestration. How do we scale these agents? How do we get them working autonomously and get them working in production? So using Strands agents or using Bedrock AgentCore, it's simple. We can, in our agent, we can decorate the agent with an entry point. So we have app entry point, and that decorator goes into the orchestrator. And we can see here with this pattern, I'm actually using an action pattern in the payload. So I have 2 actions. I've defined a chat action and an orchestrate graph action. The chat action might allow a security analyst specialist to actually chat with the agent and ask it about specific incidents that it's worked on and do some additional research, maybe perform additional actions. The orchestrate graph agent is the automation workflow. So in the architecture we looked at earlier, we have guard duty findings or Amazon inspector findings. You may have findings from a third-party system that you want to feed into a Lambda function and automatically invoke your agent. Well, when you do that, you want the agent to return immediately. You don't want to wait for, if it takes 5 minutes, 10 minutes, 15 minutes for it to do its research and do its job. You don't want the Lambda running, waiting for that response the whole time. You want it to get a payload back immediately. So that's where asynchronous invocation comes in, which is supported by multiple frameworks, Strands agents, Bedrock AgentCore. So in this pattern, the agent, we pass in the payload, the guard duty finding details to our agent. We give it an asynchronous invoke, and that will return a response basically saying, I've started my job. Now what's happening in the background is the agent continues to run in the background on Bedrock AgentCore and continues to do the work that it needs to do to complete the remediation.
Yeah. Basically, your orchestration agent is going to take care of the flow. Once you receive the alert, the orchestration is going to work with multiple agents And these agents are specialized in their specific role. They gather the information, containment, and create the report, and then pass it back to the orchestration agent to summarize everything and then publish it back. Yeah.
So we have our agent, our complex agent. Now we want to deploy it to production. So for that, I'm going to use the Bedrock AgentCore toolkit. It's something that you can download as part of the SDK or libraries available for AgentCore, and it provides some simple commands as a CLI program. So I can just go through configure, and I'm going to pass in the configuration, the entry point. So I may have multiple Python applications within my folder. I'm working in the folder that the agent exists in. Configure, here's the entry point, and it walks through a wizard to build out the configuration for my agent. It'll pick a default name based on my file. It will identify that there's a requirements. This is built in Python, so that's the requirements file. It gives me the option to do a direct code deploy or a container deployment. I'm going to choose direct code deploy for this use case. It gives me the option to choose a Python version and execution role. So if you've created that role earlier, you can pass that in here and give your agent the access to do the mutative actions. S3 bucket is for the code hosting, authorization configuration. I'm going to use IAM authorization, which is the default. The header allow list, that's for use cases where you want to pass in additional headers if you have, if you want to invoke your agent from third-party systems and use that OAuth token and pass it through. So say you have a user or a system that already has an authorization token, you want to pass that through to your MCP endpoints. That's where that header comes into play, and then I'm going to skip setting up memory for that. So my agent is configured, and then it gives me the next steps here. I can just simply do AgentCore launch. And that will actually deploy my agent to Bedrock AgentCore in production. It uploads the code, does all the prep work. So it makes it very simple to actually get an agent up and running and testing. And then, of course, there's a few other steps available to you. You can continue on doing things like invoke. You can invoke your agent from that command line. You can destroy the agent for your teardown scripts so that you're cleaning up. So that makes it really easy for you to set up and test your agent in production and get it deployed. Of course, other infrastructure as code patterns are supported as well, Amazon AWS CDK and CloudFormation. All right, so we want to provide some tips and tricks on how to get more deterministic behavior out of your agent. Sometimes if you've built agents, it can be challenging to tune the prompts and get everything working directly as you want. So a few things that we recommend are, one, within strands, you can use pydantic models to define structured output for your agents. So what does that look like? In the case of the investigation agent, we've defined a class based on the base model, and I've just given it three simple things. I want a response message, I want the list of affected resources, and a severity. And then I can pass that in when I invoke the agent. I can pass in that structured output model. What that does is, suppose after the investigation, you have a service where you want to iterate through the resources affected, and you want to perform some additional logic on those. Rather than having to parse the agent response as plain text, this gives you a nice object format that you can use. Another pattern is to use hooks within your agent. So the Strands framework provides the capability to use hooks. And what this does is, suppose in your use AWS tool, you have some things that are tagged as production, or you have some resources that you want to make sure behave in a certain way. The hooks allow you to interrupt that tool execution, or either before or after, interrupt before the model actually runs to execute in that agent loop, and you can perform additional actions. So you might interrupt when the tool event calls if you detect that the use AWS tool is being called, and you detect that the action is stop EC2 instance, and you want to add some additional logic there to say, do this, don't do that. That's what hooks will allow you to do. And then finally, you can actually nest multi-agent patterns. So we've talked a lot about remediating EC2 instances, but your environments aren't made up primarily of EC2 instances. You may have things in ECR, you may have Lambda functions, you may have databases in RDS or other systems. So you can create multiple remediation pattern agents following your runbooks and use those in a multi-agent pattern. So you have a graph that takes care of just Lambda functions, and that can be a child graph of your main graph that does your full SecOps workflow.
Yeah. So these are the QR codes for our services, and we're going to post the solution soon into our samples, GitHub samples. And from your mobile app, if you can fill out the survey, so that would be helpful for us. Okay. We are here for the next 10 minutes in the hall. If you have any questions, please stop by here, and we'll be happy to help.